And our session is being recorded. Okay. Now, a couple of administrative announcements. Remember, your second assignment, which is the first individual assignment where you're building at least two models, one unsupervised, one supervised, is due at the end of this week, which would be Sunday midnight. So, you want to do that. Now, again, some of you have asked various questions over the past few weeks. Good questions. I'm always open to questions. I want to again caution you, if you haven't yet done your assignment, you better get going, but don't try to do too much. Remember, the idea behind the modeling in this course is to give you some acquaintance with modeling. I know you had a little bit of that in Data600, and let you try a different software package. There are many software packages out there. Prediction has some pretty good clout behind it. So again, what causes problem, of course, is if you say, well, I'm going to go get the world's largest data set and try to cleanse it and do all kinds of things. No. There are data sets like that out there at Kaggle and elsewhere. And I don't discourage people from saying I'm going to do it no matter what, because that's obviously harder and worth extra consideration in grading. But I always warn people that unless you have some experience in this, it's probably going to be a very difficult thing to do with your first shot out of the box, or even your second or third shot out of the box. So the data sets that I've provided are smaller, much smaller. They're adequate for this assignment. Be careful which ones you pick. They're not all robust in the sense of having lots of inputs, a good, clear, defined target if you're doing a predictive model, a reasonable number of cases. The ones that are a little bit bigger than that are at the UCI database. University of California, Irvine has a bunch of data sets out there that are have been used for many years, that are in reasonably good shape. They're certainly larger in terms of number of cases. So you kind of have to decide how comfortable you are. Again, the minimum is to get two models built, one of each type. Explain your results, for the predictive model especially, with the accuracy charts that are appropriate. And for the segmentation or clustering model, or association, should you choose to build that, in other words, the unsupervised model, basically you just have to see if you can glean any insights. Sometimes they show up, sometimes they don't. It doesn't always turn out that modeling is successful, but what insights did you get, and so forth. And that's hard to define, I know, but it's something you'll be comfortable with. So you're getting a little bit of experience with that in this course. Then, of course, the heavy lifting for modeling comes in the Data640, where we use SAS Enterprise Miner, much larger data sets, etc. So I'm going to try, assuming my internet cooperates, I'm going to try to build another walkthrough of prediction with a little model, and spend a little bit more time focused on explaining and illustrating some of the accuracy charts, because I've had some questions on that. Again, the key accuracy charts for predictive modeling would be the classification matrix, because that tells you how many you got right, how many you got wrong. False positives, true positives, false negatives, true negatives. Always important. It's more important for sometimes, in some cases, for to minimize your false negatives or your false positives. Can't minimize both. There's a trade-off. I'll talk a little bit about that when I do the walkthrough a little bit more. But you take the accuracy charts if you build multiple models, and you look at them and say, well, which one's most accurate? Same thing with the ROC curves. The ROC curves, receiver operating characteristic curves, give you an idea for how good the models are vis-a-vis each other, and whether any of the models are any good. We'd like to see an AUC, area under the curve, which is how much of the curve is covered by the ROC curve. A really good model would be 0.9 or 90%. A decent model would be 80 to 90%, and a good model would be 70 to 80%. You get below 70%, you're really not much better than sort of random guessing, but, sometimes that's as good as you can do. So the ROC curves are good for sort of comparing classification models, predictive models, and the classification matrices are good. You can use other measures too. You can use lift and things like that. But, in order to really have a good feel for lift, you need to have like some cost figures and things like that, where you'd be able to trade off the cost of mailing to everybody versus the cost of mailing to 70% versus the cost of mailing to 30%, that's 30%, and so forth. So I don't really have enough kinds of problems like that, although I'm looking for more for future classes. All right, well, I hope that clarifies things a little bit. Again, end of the week, Sunday night, deposit your assignments in there. Now, people also have asked, can I put some screenshots in my write-up? Yes, selective ones. I don't want 5-6 pages of just screenshots with no explanation of what you did. You can always have an appendix and put some of the material in an appendix, but the write-up should include any real interesting screenshots. Leave that to your determination, as well as some explanation of what you found out, which model seems to work best, a little description of your data set. Those are kind of the normal things. So you're writing a report for someone who would receive this and say, oh, I see what they did and why they did it, how it came out, so forth. And again, it's partly to get you accustomed to building predictive models and partly to get you through our second third of the course, which says, we go from framing to building models to presenting. So it's kind of an important thing. Now, that segues us nicely into week 8. Again, a relatively short week for me chatting, but relatively busy week for you, and that's why I keep it short. But week 8, we're segueing into that third third of the course, so that third major meme or theme of the course, which is, okay, remember the Davenport model. Frame the model, frame the problem, build the model, sell and operationalize and implement the answer. There's we're seeing more and more, too many data scientists are good at building models, but not good at explaining or selling or turning them into operational actions. Okay, so you build a model that does a great job of predicting whether someone will churn, meaning leave the company. Okay, great. So Steve Canode has, according to your model, an 80% probability of churning. What do I do about that? This sort of ties us back to where we started with James Taylor, because remember, one of the model that he used was, what kind of an offer do I make to someone who's possibly going to churn, and where do I cut that off? Now, in the announcements section, I put a link to, either I did put or I will put, I can't remember because I've been doing other things here, but I put a link to a little video that I might show a little bit of tonight from 11 Ants. The video from 11 Ants. 11 Ants is a strange company. I've worked with them for a few years, off and on. They're in New Zealand. It's another small predictive modeling company. The ants are really different models they use. I'm not sure how they got that name, but ants can lift their own weight and so forth and so on. But in this video, the owner of the company, Tom, goes through a scenario that's a little bit more complete than most. Because first he builds a predictive model, a churn model, so to speak. Well, it is a churn model. But then he takes it this next step, the final step, which we don't do much of. And that is, he says, okay, we've got the churn, now what do we do? And then he puts some cost figures there. Here's the cost of mailing an offer to someone. Here's the cost, of course, of mailing to someone who wouldn't have churned, and so forth. And goes through in very clear, non-technical terms how to now implement the results of your model. That's one way. Now, that's using a churn model that's more of a predictive regression model. We can also implement models relatively easily, or much easier than that, if we use decision trees, which turn directly, as you know, I think, into rules. You follow the path down the tree, and that's a rule. What you will see when we get to weeks 9 and 10, we'll have a 2-week experience with Big ML. Big ML. ML stands for machine learning. I've mentioned this before. And Big ML does a couple of things well. It does clustering probably better than anything I've seen, but we don't spend a lot of time on clustering or segmentation in this course, just a little bit. But it'll be interesting to watch, and you could try it. But it does a terrific job of building decision trees and taking that last step of turning them immediately into code of about 15 different types. You say, well, I use SQL, or I use Ruby, or I use something else. And by the way, it does also interface with Tableau, which I know you've had some experience with. So you get a big kick out of using Big ML. But let's finish up this third. So decision management systems, as you know, we have another textbook in our course written by, yes, same guy, James Taylor. And of course, you know his mantra by now, which is let's turn analysis into actions. Same as Tom Davenport in large part. We need to say we have a model, now we need to turn it into executable actions. So this book gives you some ideas about how to do that. Now, Mr. Taylor, as most guys and gals in this business are, believes that the easiest way to do that is through business rules. We're going to see. The problem with that is you can't always turn all models into rules. You can't turn a neural network model into rules very easily. You can't turn a regression model into rules because it's a formula. But rules are great. But decision trees don't always give the best answers. Okay, so we're going to go through this. Again, reviewing the perspective. This is step one. Frame the decision, and I've mapped the Davenport chapters with sort of the equivalent Taylor chapters. So if you look at Davenport, go back and revisit what we talked about for framing, you'll see Taylor in his chapter 4 of the Decision Management Systems book gets into similar, a little different slant, but he also talks about the same kinds of things that Tom Davenport talks about. Then we're right in the middle of weeks 5 through 8 here, building and refining the model. And of course, that was mostly Davenport chapter 3. In Taylor, it's mostly chapter 5. Chapter 5, for example, has subheadings called Characteristics of Suitable Decisions, a Decision Taxonomy, Finding Decisions, Documenting Decisions, Prioritizing Decisions. So that would certainly be a good chapter to read. And then Explain and Implement or Sell the Solution. In Davenport, that was chapter 4. In Taylor, that's pretty much chapter 6. Okay, Build Decision Services. In other words, he's very much more into the implementation than was Davenport. And so it fleshes that out a little bit. So we've done that. We've spent weeks 2 through 4 after getting through that first week on decision making and decision biases on framing. We're spending weeks 5 and actually on, because you may want to do more with it, on prediction. And weeks 9 and 10, we'll be talking about a software package that is designed to sort of make the implementation easier because it automatically generates rules in, like I say, 15 different kinds of code. So whatever you're using in your organization, you could inject that code directly, as you'll see when we get there. Okay, so why do we need this? Well, you know, we have information systems that store and manipulate information, all kinds of stuff. We're gathering data, as you know, on everything. You can't do anything without somebody gathering data on you, about you, with you, to you, over you, in spite of you. So we're gathering data. But most of the time, that data sits in a database. Okay, it waits for some human to come along and do something with it. Okay, so we need to have some defining characteristics. Here are some that haven't changed. In other words, the data stop and wait rather than act. We don't have systems that act on their own for the most part. We have systems that may escalate. Okay, well, they can't handle it, so they call a human. They report, but they don't learn, and they have been built to last, not to change. We have to change all that. We have to have systems that are adaptable, that are agile, they can be empowered to act, and let's face it, rule-based systems can act on their own. You've all used them. You've used things like Siri. You've used Google searches. Those are all decision systems that are basically acting on their own to a degree. Well, we're going to expand that. We're going to expand that much further, okay? We're going to get more and more capability to act, whether it's robots or Internet of Things or something. When we're collecting all this data, people want it to take action. Now, again, the question is how much action, how far are we going to let it go? I think all nuclear power plants have automated rules running them. Why? Because there are thousands of things that can go wrong, and you have to act very quickly to fix those things. And so if you had humans in the loop who had to go through a checklist and so forth, they wouldn't be able to do it in time. So we're going to empower, certainly driverless cars are going to have to act on their own. We're going to have robots doing various things who have to act autonomously. Just similar to that, we need to have decision systems in organizations that can make decisions on credit. We have credit card neural nets embedded in most credit card software, so it can make a quick decision on whether a transaction is fraudulent or not. Are they always correct? No. Sometimes they have come up with false positives and don't let you make a transaction you'd like to make. Sometimes they come up with false negatives and let bad guys and gals make transactions they shouldn't have let them happen. So there's some of the reasons. So let's talk about this. Now, one of the key articles, I think, is to read this several-part synopsis by Mr. Taylor from the IBM Analytics Summit that he attended. Because IBM has decided to cast their lot with the world of decision management, okay? They said, this is a survey, or their report actually, 75% of CEOs with mandates to transform are looking to drive better decisions. Again, it all comes down to decision making. 84% of outperforming CEOs strongly agree that translating insight into actions helps them differentiate their business. Customers want actions quickly. We want problems resolved quickly. We want items we purchase delivered quickly. We want, questions answered quickly, as do students, and that's fair. Okay, a couple of examples. I think these are very impressive. Business rules have been used by Visa to process credit card settlements. 30,000 rules. Now, I've built a lot of rule-based systems because I taught artificial intelligence courses where we did that for a few years. Now I'm teaching analytics where we build rule-based systems. Nowhere close to 30,000 rules have I ever come anywhere in sniffing distance of that. I mean, I would consider 150 to 100 rules a lot. Predictive analytics could be embedded to detect fraud as transactions are processed. That's being done today. Again, will it get better and better? Sure. A second example, predictive analytics has been used by First Tennessee to cross-sell and upsell products. There we go. That's the association kind of model. And also Amazon and places like that. Optimization can be added to help target limited budgets. And finally, optimization has been used for crew scheduling. I showed you a brief example of one form of optimization last week when we looked at Evolver. That's an optimization technique. It's an analytics, but it's at the high end, the optimization. Business rules can be added to an optimization. Suppose we were trying to optimize, we were trying to optimize where to locate those radio towers, if you recall. We could add rules to that specify, well, you can't put the tower in water, you can't put the tower in certain cities, can't put the towers in ditches, can't put the towers on highways, and so forth. So some examples. Some more examples. Satam, an insurance company. I've never heard of them, but they're identifying claims fraud. Now, that's a big deal. 70% of claims are now settled within 48 hours. I know in Australia, for example, they settle most VA, veterans equivalent of our VA, settle most VA claims in a matter of hours, whereas here, being a retired Air Force, I'm familiar with some of that. It takes years, months to years to do that. Efficiency means fraud detection, reduce its rates. Aha, you see the payoff? If you can do something with the rules, reduce your rates, you get more customers, don't you? C-Spire Wireless, predictive analytics and business rules to drive personalization. So I can have rules in there that say, okay, if you're from a certain state, you do this and that, I give you a different deal. Preventive maintenance. Now, this is a biggie. They're actually, I think I provided you with the example. It might have been in my 640 class, but there's a great example of a company that can predict machine breakdowns 2 weeks in advance out on oil rigs before they break. Now, think of the value that is. If you can predict that an oil rig machine is going to break before it breaks and take preventive action to keep it from breaking, you save yourself a lot of time, a lot of money, because once they break, it's much harder to fix. Okay, so all these things are coming. Okay, a quick review. You start with the decision. I know you're tired of hearing that, but that's where you got to start. If you don't know what you're looking for, you don't know what you're trying to do, keep in mind that even when you build these relatively small predictive models this week, you should be looking at some target value that you're trying to predict. I'm trying to predict X, and here's why. Be transparent and agile. Again, the nice thing, remember Mr. Taylor, you're showing compliance with policies and regulations, if you recall decisions first. Be predictive, not reaction. Predictions are necessary. So I've got to predict things that are going to happen and take actions before they happen. Test, learn, continuously improve. Big deal. Again, in context, we have an application context. We have a decision service, and he lays this out quite well in his book, so I'm not going to dwell on it. But, you have to be able to combine the model building with the application context, and this is the piece we're focusing on a little bit. It's nice to build the models. I love building the models, but you got to tie them to some kind of a implementation, and you have to measure performance and continuously improve. So, decision management systems. A good place to start, in addition to the required readings for the week, is this webinar that Mr. Taylor delivered. Some of the material in there will be old, but some will be new. Remember, he is one of the leaders in the world in this business, president of the DMN, Decision Modeling Notation Society, which has just been adopted, and his software is based quite closely on that. Again, he always talks about agile, analytic, and adaptive. We've talked about that before. This is his new sort of chart he tries to tie it all together with. We've got rules, optimization, analytics, we've got data, we've got approaches, we've got policies. Looks a little bit like the decisions first methodology, except now he's added some external things, how we tie all that together into action. So take a look at that, digest it. I know there's a lot of repeat material in here, but it's still good to review because we're trying to go from framing to implementing with the model in the middle. We're going to talk a lot in the next couple of weeks about business rules, okay, a lot, because that's the guts of it. If you can turn your system into a set of rules, rules are easy to implement. Rules are easy to understand. Rules are easy to change. Rules are transparent. If you've got a biased rule that says anybody whose last name begins with K pays 0.5% more on their mortgage, well, then I'd probably take umbrage at that. I'd say, my last name starts with a K. Why should I do that? You better show me some rationale for that. So rules are transparent. Rules are very easy to, again, explain and show and sort of document where they came from. It's easy to collaborate on rules. Go to the experts, people who do this, and say, what kind of insights can you give me to complement this? Now, here's what some rules look like. And you can see they're a little messy, aren't they? Several formats. One of the things that's happened, unfortunately, in the rules business is we've not had a winner, so to speak, like we have in spreadsheets. Excel stomped everybody else, wiped them out, so everybody uses Excel. So we have a standard. So if you build something in Excel and give it to someone else and they need to change it, they sort of can get in there and mess around and change things relatively easy, assuming they know Excel. We don't have that with the rules business. We have rules that are in so many different formats, which is one of the reasons why Big ML exports them in different formats, because you can see that these rules are not that intelligible. Look at this. Public void check order for integer 1 equals 0, less than number of customers, I++. So it's got loops, it's got nested stuff. It's code. It's code. Well, writing code is fun for some people, but it's a limited set. Drag and drop, visual interface, other kinds of approaches which are equally powerful, but less frustrating, and easier to understand and grasp, I think, are becoming the norm. Okay. Now, some of these you can understand. Credit score must be greater than 660 when CLTV to HCLTV, that's sort of loan value to home value, is greater than 60%. And then you can understand that, right? So how do you manage all these rules? Well, that's where business rules management, a subset of decision management, comes into play. You have to track the rules. You have to keep the rules. Now, these are easy to read. If all the following are true, the age of the driver is between 18 and 21, number of accidents it has at least one, number of traffic tickets it has at least one, then add a $8, it looks like, surcharge to the response. And the reason? Young driver surcharge. So you want to have your rules, and you notice this one comes right out of a tree. Where do we get these trees from? Well, we get them from the world of analytics. Now, there's really two ways to build a business rule system. We, in this course, are focusing on machine learning developed rules that you give, as you know, from building your models. Many of you probably built decision trees for this assignment too this week. You put the data in, the business rules software will figure out the best place to split or ask questions to split the data set into more homogeneous subsets, and it will continue to do so until you give it some stopping criteria. Okay, that's the automated system. The other way of building a rule-based system is handcrafted, where you get an expert to sit down and say, here's my set of rules, and you code those in or use some kind of software package and build those. I've done both. If you wanted to build one by hand, I would recommend the system called Exsys, E-X-S-Y-S. Go to their website, take a look at the phenomenal rule systems that have been built by hand. But they're much harder to build. They're much more cumbersome because you have to distill an expert's expertise into a set of actionable rules. With machine learning, especially decision trees, the rules come right out. Okay, they're there for you, and they're done much more quickly. So, the IBM system, what does it do? Well, remember I mentioned they're big on the rule-based system. So, first of all, they feed decisions into a dashboard. The automated decisions get fed into a dashboard so the supervisor can see what the system did. Think about this. Suppose we say, yeah, I love this. I'm going to automate many of the decisions in my organization. Okay, well, the supervisors who are seeing results of the decision saying, oh, I see you gave Canode a discount, or you gave Canode extra time, or you did this, or you did that. Why did you do that? How did you do that? Now, you can go into the code and maybe, if you're lucky and the code's not too convoluted, pull that out. Or how about a dashboard, since you all have seen Tableau and other dashboards, how about a dashboard that shows you what the system did, that you could drill down and say, oh, here are the rules behind the scene in plain English. Then we take the rules and combine those with predictions to make decisions about the maintenance work required. Then the rules find the right engineer because it matches the skill sets. Oh, I see what's got to be done. I'm going to go find the right engineer who has the skill set to do this. It also figures out what the resources need to be. Then optimization is applied to see what additional engineers might be. In other words, if I add 2 people to this, what would it get better? Would it get quicker? Kind of a project management approach. And then you do what-if comparisons, because you may have multiple ways to do it. And then everything's wrapped up and deployed, and then you look at the results again on the dashboard. That would be an ideal system, wouldn't it? IBM's working hard on this. So read about their decision management systems. So what do we need? Well, we need information, as you know. We need know-how. We need precision, exactly, because you can't be vague and say, give it a once-over. You know, that's not going to work, is it? Replace all the bearings. No, you have to say replace bearing A2.6 with bearing A3.6, and you have to show it exactly how to do it. And then how much can you automate? How much do you need done by humans? Again, we're in this whole era of the race against the machine. If you haven't read that book, or at least some of the articles, how much are we going to automate eliminating jobs? And the answer is we're going to automate as much as possible. I don't think there's any way around that because it's very inexpensive once it happens. And again, you've seen this chart many times, so I'm not going to dwell on this, but this is, again, an example of a decision management system. I know all the pieces and what's being done and how so forth. Okay. Now, again, I'm going to show you a little bit of the 11 ants model tonight. But your assignment again is due by the end of week 8. You have some guidance there. When we get to week 9, and you don't want to worry about that until you certainly are totally done with week 8. When we get to week 9, we're going to learn our last software package. And it's probably the one that people seem to think is the most interesting, certainly the easiest to use, maybe the most valuable, at least for the narrower aspect it does. It doesn't do as broad a set of things as prediction. But there's some great videos there to get you started if some of you end up with extra time. Now, I want to add to a little bit of this. Some results from a recent survey, less than a year old, or about a year old, from the lava storm people. I always like to use survey data. You probably know by now I'm a sucker for two things: great graphics and survey interesting. Because, you know, being an academic, I'm not out in the real world, so I rely on surveys to tell me what is going on in the real world. And when I find a good one, I pay attention, because I have to shift the emphasis of what we're teaching to the things that are important in the real world. That's the bottom line. So anyway, analytics is growing despite inefficient analytics supply chains. Now, what do we mean by an inefficient analytics supply chain? Well, here's what we mean. Organizations are, and this is my highlighting, the underlining, organizations find it difficult to progress an analytic insight into an implemented business improvement. That's exactly the point I've been trying to make. Interest in self-service tools growing to minimize delays. Now, I know you're all going to go out there and make big salaries as data scientists, but much of the world is going to have to do a lot of their analytics themselves. They're certainly going to have a limited number of data scientists available to help, to instruct, to deal with large problems, to certainly work with the end users. But some small and medium-sized enterprises are going to be pretty much driven by end-user analytics, which means tools like prediction, tools like Big ML, maybe even tools like RapidMiner, certainly tools like R, although that's a programming language, a little bit more difficult. I spent a little time with that. The world, second key point out of the survey, the world is dividing into big data haves and have-nots. Most companies still on the sideline waiting and watching. Well, they better not wait and watch too long. And yes, big data requires special care and feeding, because it's, you know, the problems are so much larger when you get into Teradata, where you have millions and millions and millions of records. I saw a demonstration of a bank in Hong Kong using SAS Enterprise Miner, predicting with 10 million records, 100 million records, 100 million records each night. That's a lot of records. And it was doing it in a fraction of what it took with other software. Big data currently is the domain of the data scientists. I agree, but needs more business involvement for long-term success. Business units need to be heavily involved. Again, another of the preachings I think you'll hear from me and others in this program is work with the people from the functional groups. They understand the data better than the data scientists. They don't understand the modeling, but they understand the data. Data quality concerns on the rise. Yes. When you start collecting data on everything and every person and every action in the world, you run into some problems, don't you? So, again, the biggest problem today, turning insights into action. That was 20.5% of the people responding. Okay, so this is always, as always, it's our last slide, but let me go and see if I can find this quickly. This 11-inch software. You know, 11-inch software, as I said, it's a very unusual company. Okay. And they have a lot of models. They're a little bit more obtuse, a little bit harder to understand than some of the ones here. But I think if you go there and watch, let me see if I may have that model on my hard drive, or I can pull it up rather easily. Okay, this is their little walkthrough demonstration, but it's a little bit, well, first, is the audio coming through? If it isn't, I'm going to narrate. I can hear the audio. I don't know if you all can. Anyone hear any audio when I play this file? Okay, no audio. Well, that's okay, because I want you to go listen to it anyway, but let me explain it. Let me get all the way through. First part is all about building a model and so forth. Now, again, here's our just a quick explanation. Customer ID, age, average balance, transactions per month, city, education, gender, income, and of course, we're trying to predict whether they churn or not. So we don't need to watch the model being built for the churning. I'm going to scroll over to here. Okay. 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 So from about the 217 mark on, this is a short file. You need to go watch it yourself and listen to their explanation. This is where they say, okay, we've built a model that does a pretty good job of highlighting which customers, it actually is giving the likelihood of customers churning, likelihood versus a yes-no. Yes-no would be a predictive model using classification. Likelihood to churn would be what? A continuous model using a predictive model using continuous model, estimation we call it. So in this, what they do is say, all right, well, now we've got 400 customers, new customers we have to score, the estimated percentage of the churn. Then they're going to put some numbers in here for what's the value of keeping a customer? What's the cost of communicating an offer? What's the cost of the retention incentive if they accept? The expected